How does the blockchain work? In this video, we'll talk about how the blockchain works and why this technology is revolutionizing not only finance, but also supply chain, property ownership, and insurance, to mention a few. This is really one of the most important technologies of this century, so make sure to watch the whole video to get the full picture. Welcome to Crypto Skills, the channel that makes all the complicated crypto concepts easy to understand. So let's get into it. All services on the internet, as we know them, are hosted on centralized servers under the authority of the businesses who operate them. If you wish to communicate with a service or any unknown users in its ecosystem, you must have first establish trust, which might be difficult. Blockchain technology changes these principles. Blockchain is a distributed database and a data exchange protocol that is run by a global network of users rather than a centralized authority. Anyone who meets the protocol's requirements may update it. Therefore, the parties engaging through it don't need to trust each other. Trust in the particular blockchain is enough. Bitcoin was the first real-world application to use the blockchain technology. Today, cryptocurrency is still the most common use case, although there are numerous more. Some cryptocurrencies operate their own blockchains, while others run on the blockchains of other cryptocurrencies. Why is blockchain regarded as one of the most significant technological achievements of the 21st century? When pseudonymous Satoshi Nakamoto was creating Bitcoin, he had two main things in mind. To begin, he criticized traditional finance for taking complete control of people's money, whereas blockchain gave them the power back. Second, Nakamoto also criticized financial authorities for creating money recklessly and inflating the economy. To address this problem, Satoshi included a scarcity mechanism to Bitcoin. Only 21 million coins will ever be created, and as demand for Bitcoin grows, so will the price. The following are some of the other key features of blockchain that make it such a groundbreaking invention. It's a distributed database, which means that all members of the network have access to the same database at the same time and may edit it in real time. Instead of having a central authority, there is a consensus method that assures that all nodes agree on database and protocol modifications. This implies that no one firm, bank, or government can control what happens in the blockchain. No account can be frozen, and no transaction can be halted. The blockchain is completely transparent. Through block explorers, anybody may access the database that the node contains. If you've given money to someone, you can verify it with public ledger data, and they won't have any reason not to trust you. The blockchain is unchangeable. What is written on the blockchain can't be changed or falsified in the future. This fact raises trust in the technology. So how does the blockchain really work? To understand this, you need a basic understanding of two fundamental concepts: blocks and hash. Don't worry, I'll explain these concepts in a way that everyone can understand. Blocks. Every several minutes, Bitcoin holders send a pack of transactions to each other. These transactions are grouped into blocks, which are then validated by miners. They do this by solving complicated mathematical problems that need a lot of processing power. The first miner to solve the challenge submits their proof of work to the Bitcoin network, demonstrating that they have discovered the best solution for the block. If the network agrees, the miner obtains the mining reward as well as the ability to add this block to the database. Currently, 6.25 BTC for a block. This block will remain in the database forever and will never be changed. The database looks like a chain of these blocks. That's why we call it the blockchain. Hash. Now, we mentioned a mathematical problem that miners solve to validate blocks, and this brings us to the second fundamental concept, hash. A hash function is used to solve this problem, which is known as hashing. A hash function is a mathematical operation that transforms input information of any size into a fixed number of characters, which looks like an array of letters and numbers. The SHA-256 function is used by Bitcoin. It can convert any input into a unique combination of 64 characters and numbers. Minor changes in the input result in a complete change in the output. You may try out SHA-256 online, and I'll leave a link to it in the description. It's actually quite fascinating how this works. After hashing the word Bitcoin, we'll receive the following hash. B40560DF6691FADC7285302DDAD345D65 FEAD3EAD9299609886E2344EB63AA4. That's a mouthful. But if we hash Bitcoin with only lowercase letters, we get the following: 6B88C087E1C5B8192A70E3247B. Totally different. The process of hashing any quantity of data is relatively quick, as you can try out yourself. Your wallet will show the transaction hash, a unique identifier that helps you to monitor the transaction in a block explorer whenever you send a transaction. But why is it necessary to hash blocks of transactions, and why is it so difficult? When new transactions are sent across the Bitcoin network, miners pick them up and hash them several times. As a consequence, we receive a single hash for all transactions in a block, which we refer to as the Merkle root hash, and the entire structure is known as the Merkle tree. One of the three min block components is a Merkle root. The two others are the hash of the previous block and the nonce, a random number. We will explain what it serves in a minute. We can quickly get the hash of the block by hashing these 3 bits of data. The problem in mining is that this hash must match to a single criterion. There should be numerous zeros at the start of the string in the output. Here's what block 700367 hash looks like, mined on September 13th, 2021. To get such a hash, you need to vary the nonce multiple times because you can't guess in advance that nonce will correspond to the needed hash. People acquire specific hardware, GPUs, and ASICs to obtain an edge in computing it as quickly as possible because they have to do it so many times. Now, why is this important? The more zeros that must be present at the start of the hash, the more difficult it is to discover one. Mining or hashing difficulty exists, so that mining a block isn't too easy. If anybody could do it, malicious actors with very few resources could add any wrong information to the blockchain. High mining difficulty would need them to invest billions of dollars. Every block, as previously stated, includes a hash of the previous block. Malicious actors will have to modify all following blocks if they wish to change one block's hash, since changing one block's hash invalidates all subsequent blocks. So in a way, you could say that the massive amount of resources needed to run the blockchain is also the reason why it is basically bulletproof. Now let's take a look at how all this relates to the world of crypto. And if you made it this far in this video, I applaud you. You now know more about the blockchain than 99% of the people out there. Make sure to give us a thumbs up if you find value in videos like this. Okay, so there are 2 primary sorts of blockchain: public and private. Public blockchains are permissionless ledgers that are open to everyone. The networks of Bitcoin and Ethereum are examples of public blockchains. Anyone may join and become a validator or miner. However, for some of the largest cryptos, you need huge investments to start. To become a validating node, you must purchase specialized gear, install software, and download the whole blockchain of a certain coin. Mining does not require permissions, which is why public chains are referred to as permissionless. The true cryptocurrency boom began in 2015, when Ethereum was created with the goal of expanding the blockchain's capabilities. The platform enabled smart contracts, contracts in which all conditions are written in code and, if met by 2 parties, get executed without any further human intervention. Hundreds of developers flocked to Ethereum, where they began developing decentralized blockchain-based apps, D-apps, for lending and borrowing, games and collectibles, resulting in the first major crypto bubble in 2017. Now, private blockchains, on the other hand, can only be joined by those who have been authorized by a central authority, making them permissioned networks. Businesses are the ones who utilize them the most. Private blockchains have significantly broadened the scope of blockchain applications. They are often used to confirm the legitimacy of items, maintain ownership rights, and manage supply chains rather than powering cryptocurrency. Despite the fact that these blockchains are private, they are still decentralized data storage and exchange protocols. Consider the following scenario. A chain store wants to ensure that it purchases only fresh seafood. It establishes a supply chain that includes fishing. The fishery enters information about the time and conditions in which the seafood was caught into this ledger. A logistics company updates the status of the delivery, and the shop verifies all this information and places labels on the packages so the buyers can check the freshness of the seafood using a QR code. All third parties want to collaborate in a transparent manner, which is why private blockchains benefit everyone. Companies may use them to track the authenticity of gemstones, check the ownership of various things, and some countries even use them to run elections. The concept of blockchain was proposed long before cryptocurrencies, but its first implementation was Bitcoin. In just 13 years, the scope of its use has expanded significantly. Decentralized finance and NFTs, blockchain-based games, supply chains, and digital IDs emerged. Blockchain profoundly alters the way people collaborate. It provides consumers more control over their assets and enables near-instant cross-border payments that are free of third-party interference. But perhaps more significantly, blockchain is not overseen by any central authority, and no one can halt or change transactions at will. Furthermore, no authorization is required to create dApps, which provide decentralized solutions for a variety of situations. Now, if you want to know how DeFi works, and most importantly, how you can take advantage of this money revolution, watch this video. If you enjoyed this video, please hit the like button to show your appreciation for our efforts, and consider subscribing to Crypto Skills so you don't miss our next bite-sized explainer video on crypto. I'll see you in the next video. Take care.